how to calculate derivatives, and specifically how to calculate them algebraically. So calculating derivatives algebraically. This is all based on the formula for the derivative. F prime of x equals limit as h approaches 0 of f of x plus h minus f of x over h. So we will be using this formula to calculate all kinds of derivatives for various examples. For example, here's probably the simplest one. F of x equals x squared. Find the derivative. Again, it is supposed to be a function of x. So, how do we find it? Here is how, using this formula. So, start with f prime of x equals limit as h approaches 0, f of x plus h minus f of x over h. So each derivative actually starts like this. Now we need to replace both f of x and f of x plus h with the corresponding expression as given using the given function. F of x is the easiest, so f of x is already given as an expression, so it goes here. So it will be limit as h approaches 0, quotient, denominator is h. Numerator will be quantity minus another quantity. And the quantity that we subtract is just f of x, which means it will be precisely the given function, so just minus x squared. As for the quantity here, it says f of x plus h, and that means that we are plugging in x plus h for x in this formula. It's like we kind of physically or mentally erase x and put x plus h instead of that. And then of course it becomes x plus h, all of that squared. So I will put x back here, but what we have in this formula is x plus h in parentheses squared. That's the first step. Next step is to expand this x plus h using proper algebraic rules. Some students make a mistake saying that it must be x squared plus h squared. No, it's not that. So the proper formula from algebra, maybe I'll put it here. So using the, I will put it again as a reminder from algebra. A plus b in parentheses squared expands as x squared plus 2ab plus b squared. So x plus h, to get x plus h squared, x is my a and b and h is my b. So it will be x plus h squared is x squared plus 2xh plus h squared. And this is exactly what goes here. So the next step, after expansion, so we get x squared plus 2xh plus h squared. Now the rest of it minus x squared will stay. The denominator will stay. So now we need to decide what to do next with this. What we can do is we can cancel x squared with negative x squared, so we'll cancel that. And after cancellation we get 2xh plus h squared. So maybe I will rewrite this. So limit 2xh plus h squared over h. What can we do next? Next we would like to cancel this h. And in order to cancel it properly, we need to factor it out first, because we can only cancel a factor, so we have to make it a factor. And to make it a factor, we need to factor it out, and it factors because there is h here and h here, so if we factor it out, it will end up h times, and when we take out h of here, we get 2x, plus, when we take out h out of h squared, so there will be another h left, so 2x plus h, and the denominator is just h. Now, next thing, we will cancel this h with this h. It is possible, however, there is a small pitfall here that we need not to fall into. And what exactly is that? When we cancel anything in algebra, whatever we cancel cannot be zero. We cannot cancel a zero. Everything else we can cancel. So in order to be able to cancel h with h, We need to make sure that h is not 0. However, it is not 0 indeed. Because why? Because it's about limit that as h approaches 0. When h approaches 0, it means that we, again, going back to numerical method, we plug in various values for h which are close to 0, such as 0.1, 0.01, also negative 0.1, negative 0.01. But we don't really plug in specifically 0 for h. We did that to calculate some limits before, but it's not part of the definition. In the definition of the limit, we always assume that h is close to 0, but not quite exactly 0. And that's why cancellation is allowed. Cancellation is legitimate in mathematics. So after cancellation, we just get 2x plus h. 2x plus h. And now, to further calculate this limit, now we will plug in h equals 0. So we plug in h equals 0. Like I previously said, this is, like we did limits before, this is limit of a single function, and we can just plug in, because h approaches 0, single function is continuous, so we're allowed just to plug in to calculate the limit. Now, why can't we plug in before? For example, why couldn't we plug in h equals 0 somewhere here? Because if we do it, we'll end up 0 divided by 0. And we know from previous examples that when we have limit equals 0 divided by 0, that does not mean that limit is undefined. It only means that we need to do some work. And here is the work that we are doing. So we factor it, cancel it, and we get the answer. So now we plug in h equals 0, and the very final answer is just 2x. 2x plus 0 is just 2x. So here is the deal. So we started with a function, x squared. We did some kind of manipulations, limit, cancellations, factoring, whatever works. We come up with a different formula, also involving x. And this new formula is the derivative. So once again, the derivative is a new function that has been derived from the original, from the given function. That's why it's also derivative. And so what we have just found from this example is that when the function is x squared, then the derivative of the function is 2x. Now this short formula 2x is often taught in high schools and in short calculus courses, but I doubt that they will explain you in such short courses. Typically they don't explain. They say yes, derivative of x squared is 2x, but the question is why? Why is it 2x and not 3x, for example? And the reason why, it's because it is a result of a certain long calculation. So we have performed a long calculation, we got this answer, and that's how we know that the derivative of x squared equals 2x. Now, from now on, we don't have to do it again, since we have already done it once. So now we know that the derivative of x squared is 2x, and any next time when we need to calculate derivative of the function x squared, then all we need to do is just do 2x. So that, for example, back to the example about tangent line. It was said, given that it was f of x equals x squared, and then given that f prime of 3 equals 6. Now, having this formula in mind, we don't need to have it given. We could actually calculate it ourselves, because we can just do f prime of x, because f of x is x squared. So we already know that f prime of x is just 2x, and so f prime of 3 is just 2 times 3, which is 6, and that's it. And we can do that with any x value. So it starts as a long calculation, but then eventually it will simplify a lot of calculations like this. So this is the first example. Derivative of x squared is 2x.